Okay, wrappers. Yeah. So showing you wrappers. So here we have an array list of integers. What the fuck is in this one next door? So this is an array list of integers. So it can only take integers. Now if you add a number to it, something happens to it. It's auto boxing. Okay, it changes that 89, that int, to an integer. Okay, so an array list can only take objects. Now, so I'm just going to put it in here. All numbers, all wrapper numbers, are a subclass of the superclass. Huh? Okay. All wrapper numbers are a subclass of the superclass called numbers. Okay. Now, so you can do something like this. So I'm going to create an array list of numbers. Okay, and I'm going to call it all numbers is equal to new array list number. Okay, sorry, that should be number. Now, this array list can take any type of wrapper number. So I'm going to create a double. So double d number is equal to new double 3.45, and that's d number 2 should be called. And I'm going to take an integer, and I'm going to call it I number is equal to new integer 45. And I'm going to try and create a float. Now I can remember how to do this. Float f number is equal to new float. So I have to 23.45 f. Okay, that's casting. So now I have to cast it there because by default all decimal points are a double. Okay, and it's all sorts of complicating factor. You just have to do that when you're in a float. Okay, so these are 3 different types of number. Okay, now each of these are a number. Okay, that is a subclass of number. This is the double. That is subclass of number. That is a subclass of number. So that means we can add all of these numbers to this array list. So I can go all numbers dot add. I'm going to put in d number 2. I can put in I number. And I can put it in F number. Now there's loads of other, you notice when you're typing in add, you'll see other things called add all or add at a particular index. There is loads of methods to be using in the array list class. We will be learning how to use a good few of them, okay? Because you need to know a good few of those methods of the array list class for the exam, okay? Now, that's wrappers. And the more you delve into them, the more complicated they get. Alright? If you can at all use ints and doubles, don't use wrappers unless you absolutely have to use them. That's my advice to you. Okay? So don't use them unless you have to. Because yes, you can put them in an array list, but there's other things you can do besides that. Right? Is that okay, everyone? That's all I'm going to do about wrappers for now. But there's half a chapter in the book about them. Right? And it's a pretty big chapter. Alright? So there's a lot of ins and outs. There's a lot of things that can go wrong with them. They look simple there. They're not. Okay? They're pretty complicated.
If you did a list of numbers in an array list, or sitting in an array, there's no easy way of putting them in order. Or values,
yeah, there is. There is, it's you can, there is. Okay.
You have to write the program yourself.
No. Well, what you do is you have an interface called sort. There's an interface called sort, and you can choose to implement that. If you implement sort, then you can use that if you want. Okay. I think it's called sort. Now, that's all I'm going to do in wrappers. I'm not going to do any more wrappers for now, but as I said, there's a lot more to them. Okay? Is that okay, everyone? So we're going to leave that. I'm going to export that one again. And this is still 31. So it's just overwriting the one that's there already. And there she is done. Now, so next one we're at, so that's 31, now we're going to 32. Yeah, so we're nearly there. So take a look at this one, take a look at this one. So this is 32. So com.jwtb, create a main for start off with. Create a main. Hold on a second now, I just need to look at this one here. Do I have examples in it? So this is 32. So where is 32? Yeah. We have an example. Okay. Now, so static void ex1. Now, this is all going to be about the difference between pass by value and pass by reference. Okay, so I'm going to go here. All primitive variables are passed by value. All objects are passed by reference. Now, what do I mean by that? Alright, I suppose the easiest way is to show you pass by value first, and then I'll show you pass by reference. So, we have static void ex1. I'm going to have another static method beneath it. It's going to go static void by value. And that's going to take an int num and double denum. Right, so this is going to take in two numbers. Okay, so let's just say it takes in 4 and it takes in 3.5. Right, so it takes in two numbers, and what happens to the number inside of here is it's going to go num is going to be equal to num multiplied by 2. So inside here, num becomes 8. Yes? Everyone understand that? So if I pass num into here, say it's 4, so num becomes 8 inside here. Yes? Okay? Right. What I'm going to do with denum is equal to denum multiplied by 10. Okay? And then I'm going to do a print statement. And num inside method is plus num, and denum inside method is denum. Now, so what's happening here? Changing the value. We are changing the value of the int sent to this method. We are changing the value of the double sent to this method. Okay. So we're going to call this method from this method here. Yes? Okay. So we're going to have two variables. One is going to be called num, and it's going to be 4. The other one's going to be a double. We're going to call it denum, and it's going to be equal to 4.5. Now they're not the same variable. Okay? Yet. They're not the same variable yet. So what we do is, by value, we send it num and we send it denum. I've made the by value because I'm not going to be accessing outside of the class. Right, now, so we're going to call ex1 and it should display 4 and 45. Yes? You understand that? Because what we're doing is we're calling the method with 4 and 4.5. Okay, so that becomes 4, that becomes 4.5. So inside here it becomes 4, inside here it becomes 45. Yeah? Okay, right. I'm going to run it so everything is fine. I'm going to run it here from our main. And everything is fine. Right? No problem. Right. Now, what I want to do is, I want to display num and denum before I send it to the method. And then I want to see has it changed when it comes back to the method. What do I mean by that? So I'm going to go here. Before method call, num is going to be num, denum plus denum. And then we're going to say after method call. Now, so you need to follow what's happening here. So, right. So, Now, I'm going to run it. Now, so before method call num is 4 and 4.5. Okay, so it sends them to the method. So this is 4, this is 4.5. Okay, now when you pass in a primitive variable to a method, you're not actually passing the variable, right? You're not passing in the variable num or the variable denum. What you're actually passing is the value. You're just passing in the number 4. That's it. You're not actually passing in num at all. This is called passing by value. So what's passed when you're passing in a primitive variable, you're not passing in the actual variable itself. You're actually just passing in the value, which is the number 4, which is the number 4.5. So inside here, any changes that are done to num and denum are not reflective outside that method. So inside here, it becomes 8 and 45. Okay. However, outside here, it's still 4 and 4.5. Okay. So if you send a primitive variable to a method, okay, if you send a primitive variable to a method, it's not changed outside of that method. Okay, it's unchanged here. All right. So I'm trying to put.
Sorry. I don't know. I've done exactly like you. Just one strange thing, like first printing its num inside method.
Yep.
Only after that, it's printing like before method call it.
Yeah, well, before method called. Okay, so that will be printing off 4 and 4.5.
No, I know, but like order. Like first, in my case, printing num inside method.
Oh yeah, well, you have to have this before you call the method.
Yes, I have.
We discovered something brand new. So, see here, you buy value there. Okay.
All right. So, the initial value of num is 4 and denum is 4.5. Okay. When you pass a primitive variable to a method, it is passed by value, which means it's just the number 4 and the number 4.5 that is passed. Okay, I know it's a funny thing to get your head around. All right, it's a funny thing to get your head around. It's just saying right. It's saying right. So num, that's 4. So pass the number 4. It says right. That's 4.5. So it passes 4.5. It doesn't actually pass these guys at all. What it means in practice is they're not changed. Okay, so before you call the method, before the method, the values will be 4 and 4.5. After the method call, the values are still 4 and 4.5. Okay, it's because you're passing primitive variables. If you're passing primitive variables to a method and you attempt to change them inside the method, they're not changed outside of the method. Okay, so these numbers are only 8 and 45 inside here. As soon as you come back outside the method, they're still 4 and 4.5. Is that okay? Now,
but if you put this like inside, so it will be after method, it will be 8 and 45.
oh, if you put it inside here, yeah, but which I have. See here, num inside method is 8, dnum inside method is 4.5. After method call num4, dnum 4.5.
No, but I mean, like, you see curly bracket. If you will remove this curly bracket
there
on top, yeah, no.
That one?
Yes, and we'll add to the end, like,
well,
why do then change?
If you take that out, you then have a method inside a method, which you can do, but it's not that way you do it.
I know, but it will change.
Yeah, because it's no longer, it's a local variable. It's just don't do it. My advice is to now is don't do this.
Still different. Still has its own scope.
Yeah, it still has its own scope, but don't be putting methods inside methods yet. Okay. Right now, so that's passing. So that num is local to just those curly brackets. Okay. So that num is just local to here. All right. So anything you do inside those curly brackets is not going to reflect it outside the curly brackets. Okay. This num and this dnum is local to here, to here. So anything you do to those variables inside there is just going to be reflected inside there. Okay. It's not going to affect anything outside of those methods. Okay. Nothing outside of that method will be affected. Nothing. Because they're local variables. Now, methods or objects are slightly different. All right. Now, so to show the slight difference, oh, I might just see now. Hold on a second. Where's the dog? Right. I want us to create a dog class, please. And I'm not going to put a constructor, but every dog is going to have the default age of 10. And it's going to have the name of Andy. So I'm going to go in here. So this is going to be static void ex2 to avoid any confusion. Static void ex2. And this is all about pass by reference. Now, we're going to create a dog. Now, when you create a dog, every dog is going to have the age 10 and the name Andy. Does everyone understand that? How do I know that? Because there's this. Okay? So every dog we create will have the default age of 10 and the default name of Andy. No, they're not statics because everyone has the age 10. Okay, they have their own age of 10.
Yeah.
Right? So a static is just once. So if you have 10 dogs, you have 10 ages of 10.
Yeah.
You have 10 dogs who are called Andy. Alright? As opposed to, let's say, course ID is just one of them. Okay? Right. Now, so we've created a dog. So this dog is called, has the age of 10 and has the name of Andy. Right? Now, I'm going to create another method down here. And this is going to be private static void by reference, by ref. and this is going to take a dog. Now, what I'm going to do here is, the dog that was sent to it, I'm going to try to assign a new dog to it. Alright, now, bear with me a minute when I'm doing it. Alright, now, I am going to, so we're back here in static void ex2. Okay, so just to clear sure we are, end of ex1 method, end of ex2 method. Right, now I'm going to go here and I'm going to change the name. So spot has a name of it, and so put it here. The dog just created as a name of Andy and an age of 10. So we will change both. So I'm just going to go here. Spot dot age is equal to 50. Spot dot name, we're going to change it to spot. Now, what I'm going to do is I am going to, so just to be sure that everything is a-okay, I'm going to get the age of spot, and then name of spot. Now it should give us 50, and it should give us spot. Okay, just print out that first. Just do that first. Just do this for a second. Right. Now, what I'm going to do is I am going to pass. So I'm going to run it. I'm going to comment out this guy. I'm going to put in the other one. Right. So, age of spot is spot.age. Name of spot is spot.name. Everyone see that? Yeah? Everything so far? Right. Now, I'm going to go down to this method. Inside this method, I'm going to print off name. So, inside method, name is spot.name. SYSO inside method name is plus spot.age. Alright, now I'll finish out the code and then I'll explain what's happening. Now I am going to call the byref method up here, and I'm going to send it the dog spot. And then I'm going to say here as well, after method call, spot.age, right. Now, so we changed the name of spot. Let's change it to 50 and spot. Okay, so to print off age of spot is 50, name of spot is spot. And go down here. So becomes this dog. Now, inside here, what we do is we assign Spot to a new dog. Okay, we assign Spot, a new dog to Spot, which means that inside here, this is going to say Andy, and this is going to say Tim. Now, where does it get those variables from? It gets those variables from because when we create a new dog, it automatically assigns the name Andy to the dog and the age 10 to the dog. Everyone with me so far, yes? Everyone with me so far? I'll even prove it, I'll run it. Alright, so this prints off age of Spot is 50. Name of Spot is, hold on a minute, I need to scroll up the screen a bit. Right, so age of Spot is 50. Name of Spot is Spot. Now, goes into the method. Okay, so it's a brand new dog. When you have a brand new dog, automatically given a name of Andy and automatically given an age of 10. So inside method name is Andy, inside method name is 10. Now, when you try to change what an object refers to inside a method, it's the exact same as primitive variables. Alright? So if you try to assign a new dog to it, it's only inside here does it refer to new dog. Outside of the method, it's still the same dog that was 50 and Spot. So after method call 50, after method call Spot, it's still the same dog. Okay, I have passed a dog into here. I tried, so inside here Spot refers to a new dog, a brand new dog that has the name Andy, a brand new dog that has an age of 10. However, outside of the method, it's still the same dog, which was Spot, and has got an age of 50. Any questions on that? Yeah?
One question there, no, say the practice station by ref, right?
Yeah.
You got parameter there, the Spot,
yeah.
which is a dog.
Yeah.
And then in the method you said we created
a new dog.
Gave it Spot. But there's no connection between the Spot that you created and the Spot that's passed in as a parameter.
Now, you would think there isn't, but there is, because I'm going to show you the connection. Okay? Now, what you can do is, just like with the primitive variable, right? So, I'll put it in here. If you try to change what the object refers to inside a method, the dog originally referred to does not change. Okay, the dog in ex2 will still be the dog that is called Spot and has an age of 50. Inside the method, it will be a different dog with a name of Andy and an age of 10. Okay, so
I can understand that because there's no connection.
Yeah, right. But right, so you can change what the object refers to. However, you can do this. So I'm going to create another method. Private static void by ref 2, and we send it a dog. Now, inside of this method, we're not going to change what the dog refers to, but we're going to change the name of the dog. I'm going to call this dog Rex. Because when you send an object to a method, if you change one of its attributes, it's also changed outside of the method. Now, what do I mean by that? Okay, so I'm not going to be able to fit on one page, so I'll write down the method here. So the method is this: private, static, void. That's not fitting on the screen. So I'll go private, static, void, by ref to dog spot. Okay, now all I'm doing inside the method is I'm changing the name of this dog to Rex. Okay, that's all I'm doing inside the method. Alright, now, so I'm going to go by ref 2. Now, spot before it's in them has an age of 50 and has a name of spot. Do you ever understand that? Before we send it to this method, it has an age of 50 and has a name of spot. I'm going to call the method by ref 2 and I'm going to send it spot. Alright, so SYSO after method call, after by ref 2 method call. Now, age hasn't changed, so you know it's the same dog. However, name the name has changed. See here? When you pass an object to a method, right? You can't change what the object refers to, but you can change the attributes of the method. So you can change the age of the dog, you can change the name of the dog, you can change the weight of the dog, you can change the height of the dog, but it will still refer to the same dog. So if I pass in my dog to a particular method, that method can change everything about the dog, but what comes back is still going to be my dog spot.
Sorry, but after that, like what we done, is this like all dogs now name Rex?
No, only this dog is called Rex. Okay, or alright, we'll change the age so that'll make it a bit more. So if I go spot dot age is equal to spot dot age and multiplied by 2. Okay, so age Spot's age was 50, now it's 100. Okay, this is a central plank of Java. If you send an object to a method, alright, you can change the attributes of that object. You can change the name, the weight, the height, the sex, whatever you want about it, but it's still going to be the same object that comes back to you. Alright? So you can imagine a situation when a dog eats something. Alright? What's going to happen to its weight? Going to go up. Okay? When a dog mates with another dog, it's going to produce another dog. Every day a dog gets older, so their age is actually constantly being updated. Okay? So here you can see before the method call it's 50 and spot. I pass it into this method, it doubles the age. Inside the method the age is doubled. Okay, so just to show you, SYSO inside by ref 2 age is it's 100. Okay, and it's also changed outside of the method. Okay, after by_ref method called age is 100, but see the name is spot, which tells you it's the same object. The dog's age has changed. Okay, his weight can change, which makes sense. You should be able to do that. So objects are passed to methods by reference, which means you can change what an object refers to if I pass my dog into a method. It's my dog that comes back. It's my dog that back, but you can change the attributes of the object. I can change the name, age, weight, height of the dog, and all this will then be changed outside of the method. Okay, so you can change the attributes of an object, but you can't change what the object refers to. I throw my dog into the method, my dog is going to come back. He could have had a sex change, he could have changed his name, he could have got heavier, someone could have chopped off his legs. That means he's not as high as he used to be. Okay, so you can change attributes. You can pass an object to a method. You can change the attributes. You can change what the object refers to. That's called passing by reference. All objects are passed by reference in Java. All primitives are passed by value. Any questions on that? No questions? As I said, we will be coming back to this as well. Okay, passing by reference is something you need to get a handle on. Alright, you need to get a handle on that. It's fairly important when it comes to Java. No questions? As I said, we will be coming back to it. Alright, so that was 32. Quickly export that. So that is 32. Finish. Alright, so this is alright, you're not lying back to go smoking. Go on. If you want to go smoking. Alright, now so that is that pass by reference, pass by value. Okay. Now I'm going to do our next one, which is going to be 33. So I'm nearly there. It's new. Java project. This is 33. No, there's one more. Hopefully we'll get it finished. This is a very short one. Okay. Now this is something called exceptions. Alright. So just go new package com.gratb new class. We're just going to main in it, okay? Because we don't need anything else in it. Now, so when we create this guy, so it's equal to 45, 67, 88, and 99. Okay, so we loop through that by going int I array I. That'll print out all the numbers. Okay, so creating an array of size 4, looping through our array. Now, so if I do something like this, so this goes from 0 to 3. 0, 1, 2, 3. Yeah, it's array numbering. Yes? Everyone understand that? So if I do this guy, num array 4 is, I'm going to go plus array 4. Okay. This generates an array index out of bounds exception. Okay. So put it in here. This generates array index out of bounds exception. Okay, as array numbering starts at 0, so 4, so an array of length 4 goes from 0 to 3, so this is out of bounds. Now, so this generates something called an exception. Now, exception, it's not usually a fault in the code. It's a fault in the logic of the code. Okay? Now, when you're dealing with the exceptions, you deal with them via something called a try-catch block. I'm going to show you what a try-catch block is. Okay, so try, it goes like this. Try. You have curly brackets. Okay, now try is always accompanied by either a finally block, but it's more often than not by something called a catch block. Okay, now, so I'm going to put this code in here. Okay, so what happens is the following. All right, I attempt to run this code. Okay, now normally if we run that code, it's going to crash our program. Kaboom. All right, now what a try catch block allows you to do is that won't crash your program. What happens is that does something called, it throws an exception. Okay, it throws an exception. Now, if the exception isn't caught, your program will crash. So imagine this guy throws out the ball. The ball is called an exception. But hold on, this dude catches it here. Okay, he catches it and he can do whatever he wants with it. Now, all we're going to do inside the exception is, or inside the catch block is, print it out. The exception is plus E. Okay, so now this may or may not produce an exception. Okay, we don't know at the time of running does this produce an exception or not. If it does produce an exception, it is thrown out. And when an exception is thrown, it's always looking for something to catch it. This guy catches it. Okay, this guy catches it, and there is an object in Java called an exception object. So it's catching the exception object, and it gives us the name E. Okay, then it'll print it off. The exception is E. And what's more, what's good about it is your program continues on. Okay, so your program won't crash. Just to prove that it doesn't. There we are. So that generates an exception. It's caught, and it prints off the exception is. So it's an exception object called E. So if you just put it in there in a print statement, it'll print out what it is. It's an array index out of bounds exception.
So if you have like a few crashes, yes, like one you already put it and found another one, can you put together?
You can. You can have multiple catches.
But it needs more E or something.
You can have multiple catches, right? You can have one try, but you can have multiple catches. So keep going. Now, this is just a very, very brief introduction to try and catches. There's two different types of exception. There's something called a checked exception, and there's something called a runtime exception. A runtime exception is something that points to an error in your code. There's also something called a checked exception. A checked exception is a situation where you have to put in a try-catch block. For instance, when you're connecting up to a database or a file in Java, you have to put all of the stuff to do with your connections inside a try-catch block. Okay? So if you're connecting to another file, if you're connecting to a database, you have to put that connection inside a try-catch block. The reason being is, if you're connecting up to an external file, it's something that's not in control of this program. Someone may have deleted the file. If you're connecting up to a file on the other side of the world, the internet might be down. Alright? So what you have inside this try-catch block is here, if you can connect up to a certain file, do something else. That's what it allows you to do. So try-catch blocks. This is the topic in the exam that's asked the most. Would it be right, Victor? There's a lot of questions on it.
Yeah.
Okay. The reason they ask a lot of questions in it is because people do not like it. Dealing with.
What kind of question?
Well, I can't go into any more detail. Yes, they're all looking at us again. Hello. What sort of questions? Right. There is 15 exceptions you need to know. Okay, and the exceptions do certain things. You need to know what to do. That's the first thing. The next thing is you can have one try and you have multiple exceptions or multiple catches after it.
Like if you not put another catch, like if you have, let's say, a few errors, it will be exactly the same like previous.
There is different types of exceptions. Okay, one thing I didn't cover with you with the methods is that when you catch an exception, okay, exception is a superclass of all other exceptions. There's around 15 other ones. So that guy can catch any exception.
No, it means it's different. Like, okay, we have another exactly same line, let's say have 6.
Yeah.
System, yes, and system print, it's, I will add one more, it's always will print 4,
yeah.
Not 6.
Well, yeah, well, it go to 4 because it never gets to 6.
No, but if I will put 6 here and second one will be 4,
yeah,
it will print 6.
Yeah.
Like only.
Well, it's the first exception. That's what triggers it.
Only first exception.
Yeah, well there is ways around
because for me it was like answer number 4.
Yeah. No.
The second one it's have no answer.
No. 6. Okay. So it'll always trigger the first step. Now there's a lot more to exceptions than that. This is just a brief introduction. A very, very brief introduction. And as I said in the exam, this is the thing that they ask the most questions on. Because people don't like them. Because traditionally people just shied away from doing them at all. If you don't connect up to a database, or if you don't connect up to a file, which, let's be honest, you are going to be doing. If you're doing any sort of program, you're going to be connecting up to files, you're going to be connecting up to databases. But if you're not, you don't need to use try and exceptions at all. But if you're connecting up to a file, if you're connecting up to a database, you have to put the connection inside a try catch block. Okay? Now we don't do, databases are not on the exam. Connecting up to files are not going to be on the exam. But I'm going to show you how to do them on C. Okay, so, and you can't do that without a try catch block. Okay, so what I'm going to do is I'm going to copy and paste in the comments. I have comments for this done already, and I'll upload it and you can have a look at it.
So 24, yes?
Yeah, this is 33, yeah? So put this inside here. Now I do have a bit done on lambdas, but I'm not going to do lambdas, okay, because I'm just not going to do them because they're too confusing for now. Oh Jesus, we have to, yeah. Oh yeah. So we've only one thing left to do now. Now, by the way, this doesn't have to generate an exception. Just to show you one last thing. If I change that to 2. Oops, sorry, wrong one. If I change this guy to 2. Then no exception is generated. Okay? Catch only catches an exception if an exception is run. Or if an exception happens. Okay? That doesn't generate. This guy does. So that creates an exception object. Okay? Creates an exception object. This catches the exception object and names it E. And then the exception is E. It'll print off array index out of bounds exception. Okay? Now there's more to exceptions than that. And let's say we will come back to them, but we won't come back to them for a good while yet. They're the last topic in the book. So another month or so. Or 2 before we come back to them. Alright? Now, this is our last file. But hey, 4.5 weeks. Okay, so we did a lot in 4.5 weeks. So this is F34. Now, so I want to make sure I have all the right stuff here. Alright, so I want you to create a main. Hold on a second, I'm see where's this file. Fucker here. So just main and animal, please. This is 34. And new class main finish and animal. New class animal. Now, so in the animal class, I'm going to go int age. I'm going to string name. And I'm going to go static int count. Now, here, what is this about? This is about initializers, something called initializers. Right, now, so here are the rules for initializers. Statics first, then non-statics, then constructors. Now, what's an initializer? This is an initializer. That's an initializer. Right? If you just have brackets with nothing before it, that is an initializer. And what do you use initializer for? You usually use initializer to give it initial values to your... Now, up to this, we have been doing this. Now that's initializing the values. That's fine. Okay? There's nothing wrong with doing that. But it's better to use these guys. Alright, so now this is a non-static initializer. So I just go age is equal to 23. Name is equal to ND. And to show that the initializer is being called, I just say animal initializer called. Now, what is this guy? This is initializer. Yeah, I'll just show you now. Okay. It is just falling into. That's exactly what it's doing. Right, just show you. Right, so this is a non-static initializer. Alright? Now, if I have a constructor, animal, I'm not going to give any values to the animal. I'm just going to have inside the animal constructor, I'm going to have animal constructor called. Now, when I create an animal, what's going to happen here is that these guys are always called before the constructors. Okay? You can have as many as you want, by the way. You can have a few animal constructors. You can have a few initializers. So I'll have another initializer. Another one. And all I have in this is second initializer.
And if you put initializer after animal, it doesn't matter, yes?
Yeah, right. So let's say I put it in here. Down here. Alright. The way it works is that it'll do the initializers first, and it does them in the order they are in the file. Okay, so it'll do this one first, then it'll do this guy second, then it'll do this guy third. Alright, so just to show you, I am going to create an animal. So I'm going to go animal nd is equal to new animal. Oops, I have an error. Oops, cancel. Now, animal initializer called, second initializer called, animal constructor called. Now, why would you have these initializers in it? Before you create an object, you might have to prepare the ground. You might have to prepare something else. Before you can create a cat, you have to create a kennel for your cat. Right? Before you create a person, you might want to create a house for your person. So in the initializer, you could create a new house. Okay? So that's what initializers are for. There's something that run before the constructor. Okay? Now they always run before the constructor. Now, you'll notice that I have a static called count. Now, this is a non-static initializer, so that means I can't access. Well, actually, you can. Okay? You can access statics inside a non-static. However, if you declare your static initializer, so I'm going to put it down here. Okay? So I'm going to declare initializer and I'm going to make it static. Okay? And I put in this. This only runs once. Alright? Now, what that means is the first time in my program that I create an animal, alright, it's going to go the static first. Then it goes to this initializer. I have another initializer down here. And finally it does the constructor. right? However, after my first animal being created, it won't call that because it's a static initializer. Remember, statics apply to everything in your class, so they're only created once. So static initializers only run once. Okay, so if I go here, go back to main, I'm going to create a second animal. Animal Angela is equal to new animal. And we have a look at our printout. This only runs once. And yes, it only runs once. Okay, that's the static initializer. Then we have an animal initializer called, second initializer called, animal constructor called. See, for our second animal, the static initializer is not run. Okay, so what are initializers for? Initializers are if there's some preparatory work to be done before your object is created, you bung it in an initializer. Okay, is that okay? It's not that difficult. Again, they usually ask questions of that. So, static initializers. So I put it down here intentionally to show you that they don't go in order. Now, if I had another static there, the statics will run in order. So it'll always do statics first, in the order there in 5. It'll always do non-static initializers in the order there in 5. Okay? So I'm just going to copy the comments for this. So this is the comment. Okay, static initializers run first. So instance initializers. This runs before the constructor, and the constructor runs last. Okay, so if you have a class that's a complicated object, you're obviously going to run some initializer, and inside that initializer could be could be creating other objects. Those objects could be calling other methods. All sorts of stuff could happen. Okay, so that's initializers. Now, our last topic to be covered is dates. Now, let me tell you this. You should get up every morning and pray to baby Jesus or whoever it is you pray to that you're working with Java 8 when it comes to dates. Because prior to Java 8, dates were an absolute pain in the arse. Okay? They were nigh and impossible to use with Java. They're the most unwieldy piles of shite you could ever use in your life. Alright? Just rubbish. And they were so difficult to manage, and you'd have a sore head dealing with them. Java 8 is a massive improvement when it comes to dates and times. Now, we don't do time zones, by the way, in this. The reason we don't do time zones is time zones are considered a bit too advanced. But time zones are important because, Java is used a lot now for any sort of online communication, right? So if you're connecting up to a file that's in Australia, you need to take into account the time zone that's out there. Do you understand what I'm saying? And dates and times are very critical to do anything with servers, right? So that's why time zones are important, but we're not going to cover them. I'm not going to cover them either, all right? Now, so, first of all, dates. So there were 3 different types of dates. Now, if I don't get this fully covered today, I'll just cover it briefly. I'll finish it tomorrow morning. Okay. First is just the date. Okay. Which is called in Java LocalDate. Okay. So that's the data type. So, which is in Java the LocalDate data type. By default, it's in American format, which is this shit. Yanks, go figure. Okay. Right. So here you go. Local date. Now it's good. Again, it asks you import local date. It's imported. Okay. Now the other one is local time. Time is local time, and it gives the time in 24-hour format. Now it gives it in hours, minutes, seconds, and then it goes to nanoseconds. Nanoseconds is a billionth of a second. Okay, so it does go to billionths of a second. Alright, why it goes from seconds to billionths of a second, I don't know. Why doesn't it go to fractions of a second? I don't know. That's the way it does it. Okay, now, and what does that look like? It goes local time. And again, you have to do the boy here, import local time. Now, yeah.
Does it have seasons?
Huh?
Does it have seasons?
Yes, it does.
Seasons?
Yes, well, not local seasons, but it does have seasons. Okay. Let me just have a look to see what. Okay. Local time. And lastly, so if you want a combination of date and time, the combination of date and time is the local date time data type. So what does this go? It goes in this format: y dash dash dd dash 12 23.
I'm sorry. Like you said, by default, it's different way. So when we imported local data.
Well, local date is going to be unfortunately it is that way. That is the format it is. Which
day, month, day, year.
Yeah, it goes year, month, day. I think we're going to find out fairly soon anyway. Okay, and it goes local date time. So I'm going to call it date time. And again, you need to import that guy. Alright, so that's that imported. Now, the important thing is you can't create a date or time or date time directly. Okay, what I mean by that is you can't go like this: local date, my date is equal to new local date. Okay, you can't do that. You could in the old version of Java, and that really causes untold problems. It was just, it was painful to use. So they did away with that method entirely. So the only way you can make dates or times. So I'll just put this in. So can't do that. Okay. So this will not compile. Alright, now, so you have to use methods, you have to use static methods to create times. Now, so we can do this. So I'm going to say local date, my date is equal to LOCLDATE dot now So all of the date time, all of the dates data types, they offer a method called now. What will they get you? That will get today's date. Okay. If I go local time,
From your system, is it?
sorry?
It's from your system, is it?
Yeah. It takes the time from here. Okay. So whatever time you have on your machine is what's going to show up here. Right? So that's the time. And that's today's, or the current time. And local date time, my date time is equal to local time, local date time that now. This is the current date time. I want to print off each one of those. Date is my date. Time is my time. Date time is plus my date time. There we are. So the date is the 24th. Oh yeah, that's the actual format for dates, sorry. So the formats for dates is, God, that's weird. That's really back out entirely. So it's 2019-04-24. The time is 25 past 3 and 8 seconds and 742 billionths of a second. The current date time is that guy. T represents time, which is 15:25:08.742. Okay, now is always going to be different for time and local date time. When you're running now, it's always going to be different. All right, so you can use that to give a unique number to anything. All right, if you want a quick way to give a unique number to anything, that usually will. Now there is a slight chance it could end up with, I don't know what the odds would be, but there is a chance you could end up with the same number. But you could do some sort of coding for you. So this is one way to try and get a unique number for something. Okay. Now that's local date not now. So I'll just put in this comment. Each of the above three classes has a static method called now, which your local date class will get today's date. For local time class will get the current time. For the local date time class will get the current date time. The format of date is YYMMDD. Okay, that's the way for dates is. So I should have changed that up here. So it's this one here. It is 2019 04/24. Okay, that is the time. Any questions on that? Now there is just a small bit more to do with dates, but we'll quickly cover it tomorrow morning. Is that okay? So that's dates finished, and that's us almost finished the whole lot. So we just have 34. We just have half of this file left to do, and that's the beginner's part of the course finished. And we'll start the book then after that. You all have the digital copy of the book as well, yes? It's on the shared folder. So the way I operate is I usually be reading off the book here on the screen. I read a passage from the book. We do a bit of code. Is that okay?
Actually, sorry. Last time, like, it's milliseconds, not nanoseconds.
Is it?
Yes.
You sure?
Yes. I just googled it.
Is it? Okay. I think you can actually change that to nanoseconds.
Why it's microseconds? You know, like